Okay, so for this type of problem, it's okay. So this is the problem. So they give you a chemical equation, and they give you K, and then they said that 14.6 grams of NH3 is put into 4 liters. Now they're asking for the equilibrium concentration of all three of these compounds. So the first thing you want to do is set up an ice table. Okay, so I rewrote the equation here and then set up the ice table. And the ice table stands for initial, change, and equilibrium. And a big thing to remember is that only molarity can be in this ice table. So the question said that 14.6 grams of NH3 was put into 4 liters. So what you do is first you want to make that into molarity. So you convert it to moles. After you convert it to moles, you're still not done. You need molarity, so you divide it by 4 liters, and then you get 0.214 molarity. Now since you have that, they only say that NH3 is put in the flask. That means that the other two have to be 0 because it's the only one reacting. There's no concentrations of the others. If they did give you concentrations of all three, then you actually have to find Q, which is still like this. It's still like K, which is products over reactants. But you plug in all your values into Q and determine which direction the reaction goes. Okay, so the first thing you do is now since we have the molarity, we plug in that. It's like I said, it's 0 and 0 for this because it's the only one there. And so so for this one, it's pretty obvious that since there's only reactants, it's going to make more products. So the reactants is going to decrease and the products are going to increase. So you subtract, and then the 2x, where does that come from? It comes from here, the coefficient 2 minus 2x, and so it always comes from the coefficient. So in an ice table, so and then it'll be plus x, coefficient is 1, plus 3x, coefficient is 3. So then these are your equilibrium concentrations. Now since you have your equilibrium concentrations, these are your equilibrium concentrations, except there's an x. So what we can do is just solve for x, because we're actually given K. So K is equal to products over reactants. So K is equal to N2, it's equal to N2, right? Product side, N2. The coefficient is 1, so the exponent is 1. H2, coefficient is 3, so the exponent is 3. NH3, the coefficient is 2, so the exponent is 2. So now, since we have all that, this is the coefficient constant. We can plug in all of our values, and now it just becomes an algebra problem. So from here, I just multiply the numerator, and I'm sorry, I did 3x cubed, and that's 3 times 3 is 27, 27x cubed. I multiplied these two, and so got 27x x to the fourth. And then you can do it the long way, which is like multiplying everything out, and you can do that. But I saw a shortcut here, which is if you have squared and you have something like 4, which is a perfect square, you can square root the entire thing, and then you have to square root both sides. So that becomes square root of 27x squared. The 2 on the denominator goes away. So then what you can do is multiply each side by that. K is 0.83. If you didn't see that, K is 0.83. And then multiply each side by 0.2104 minus 2x. And then those cancel. Next, what happens is, since it canceled, this is only on the right side. I want everything on one side so it can equal 0. So I'm going to add 1.82x and then subtract 0.1949. And then that leaves me with this. Now since it's in this form, I can plug it into the quadratic equation to solve for x. So I plug in, and this is A, B, and C, and I plug in all those values into the quadratic equation, and then see, this is tricky because since it's plus or minus, you'll get two answers, but it'll be obvious which one is right or wrong. Um, uh, Usually you'll get one positive and one negative, which will give it away because it cannot be negative because x can't be a negative. You can't have negative moles. Um, but if you get two positives, you'll also know because one will be too big. Let's say if it was like x was 5, right? Let's say it was positive, x equals 4.53. That wouldn't work because 0.214 minus 4 would get you like it would give you a negative number, which you can't have. You can't have negative concentration. So it'll be pretty obvious which x is right. So after you determine that, you plug it back into the ice table. So you have your x, you plug it into your ice table. So you, for each one of these are your concentrations, and you plug in x for each of these. So these are your concentrations from the ice table at equilibrium. You plug in x for each of these, and then you get 0.042 molarity for NH3, 0.089 molarity for N2, and 0.26 molarity for H2. Alright, so the last thing, these type of problems are really tedious, as you can see, and there's hundreds of places where you can mess up. Like if you not only if you like forget a negative sign here, or you forget it in the calculator, or anything, it's just a really tedious problem. So on a test, try not to do these problems. Like leave it for the last problem if you can. And then a final thing, if you don't even have time, just start from the answers and like work your way backwards and see if you can figure it out. And you can actually check to see if your answers are right, because you can plug all these in. You can plug all these in back into your K equation and see if it equals K. And in this case, it does.